Okay, this video onwards, we will be working on a new playlist called Calculus. Okay, now we will be starting with very basic concepts, then slowly we will move to some advanced concept in calculus as well. Okay, so we will take baby steps to understand the whole subject, and calculus is very interesting subject and very important too. So, and it has real life applications as well. So understanding it thoroughly will be very much important. Okay, not only for your exams are important as well, but when we will move to when we'll go to higher studies and all, when we'll do some research level stuff, there also it is very much important over here. So that's why we will try to understand calculus thoroughly over here. Okay, so this video we will start with a very basic concept called number types. Then from next video onwards we'll talk about some more interesting stuff about calculus. Okay, and initially we will try to understand what do we mean by functions and all, because understanding of functions is very much important when we talk about calculus. So initially we will study that, then we'll move to some limits, continuity, and other stuff over there. Okay, so number types. So we will start with a number. Let's say a real number. Okay, so the approach we'll take is we will first study the real number, then from there we will see how we can derive the other number types. Okay, at the last we will see the different, that the chart maybe you have seen it before. Okay, so what is real number? At its nutshell, you can think about real numbers are those numbers which can be expressed on a number line. Okay, now what is number line? That the question arrives then, right? So number line is something like this one. We have a horizontal line. It could be a vertical line as well, because if you talk about our Cartesian coordinates, right, the y-axis is nothing but another number line over there. Okay, so we have a, for our convenience, let's talk about a number line which is basically horizontal, which has a particular origin. Okay, so in this case the origin will be 0, the number 0 over here. Okay, now if we go to from 0, if we go to right hand part, okay, that means we say we are going to positive side, and we can go till positive infinity, which is a very bigger number over there. Okay, so that's one thing. But if we go to, that's positive infinity. Now if we go to left hand part of the 0, we are basically saying we are going to the negative direction. Okay, and if we just go on, we'll reach negative infinity over here. It's a very much smaller number. Okay, so that's the structure of a number line, and there are certain other properties as well. Let's talk about that. Let's say on this origin 0, we have our robot over here. Okay, and it wanted to move on the right direction, let's say positive direction over there. Okay, so let's say it is moving from 0 to 1. Okay, now the distance it covered to move from 0 to 1, if it is moving from 1 to 2, the distance it covered from 1 to 2 will be same as the distance it covered from 0 to 1. Okay, now we are not talking about the unit of a distance. It could be anything like 1 kilometer, 1 mile, anything, 1 centimeter as well. Okay, the distance is important, the unit is not important over here. Okay, so that means what you are saying is from 0 to 1, whatever distance we are traveling, from 1 to 2 you will be traveling in the same direction, same distance actually. Okay, and this is true for all the numbers over here. Okay, that means this numbers like this 1, 2, 3, this we are saying these are consecutive numbers. Okay, and the distance between them are also same. Now this structure actually help us to do a lot of stuff like addition, subtraction, even multiplication as well through the number line. Okay, so now we're talking about a real number, so that means a real number can be expressed or can be written or can be marked on a number line over here. Okay, so that's the first thing we'll talk about. The real number can be expressed on a number line with respect to an origin over here. Okay, now there are millions of real number, even infinite numbers of real number over here. So let's talk about other aspects of real number. So the first thing is we can express it on a number line. Now the real number set is the name of the set, generally we call it as capital R. We will try to remember this one because when we'll talk about some other stuff like functions and all, and when we'll say like it's this particular number belongs to a real number set, so we'll basically talk about this real R set, capital R set over here. Okay, now let's move on. So let's talk about another property of the real number. Okay, we still have the number line. Now let's say we are trying to magnify this only this person from 0 to 1. So we can write something like this one, right? So if you see from 0 to 1, there could be so many numbers over here like 0.1, 0.2, 3, 4, like this one, right? But again, if we magnify it from 0 to 0.1, we will get infinite number of numbers over here. Same thing for 0.2 to 3, same thing for other ranges over here. We'll always get a infinite number of numbers over here. That's as I said, like there are infinite number of real numbers over there. Okay, so that's why the real number, that R, represents the set of continuous values. If you see it over there, right? You see, like what kind of values we can say it's a continuous value. So according to the definition of the continuous values, it belongs to a set. It can be any set. Okay, generally for real numbers, as it is a continuous value set as well, we will talk about in terms of real number set R. Okay, it belongs to a set where there is no finite number of elements in the set. There could be infinite number of elements over there. Okay, and if you just talk about in a real life scenario, where basically we use the continuous variables or values, something like measurement of weights, right, or measurement of speed as well over there, right, even temperature as well. So this is the use cases or scenarios where we use continuous values over there, right? And always we use these guys to represent, and basically we use the real numbers to represent these weights, speeds, those stuffs over here. Okay, so there are two things we will remember about the real numbers is they can be expressed on a number line, and they always represent a continuous value, the set of continuous values. Okay, now let's talk about another variant of real number. Okay, so those are called integers. Now the Latin meaning of the integers is whole. That means they do not have any kind of fractional part, right? So if I just talk about fractions, it could be something like 3.4 is a fractional number, right? That they have a decimal point, and after the decimal point they have certain numbers over there, right? But for the integers, they are whole. They do not have any kind of decimal points and decimal parts over there. Okay, so something like, so if we just talk about this particular set over here, so if you see like 0, 1, 2, 3, 4, minus 1, minus 2, these numbers do not have any kind of fractional part over here, right? So these are all integers over here. Now it can be subdivided into more sets, something like this one. If you see, these are all negative numbers over here, right? So we call it as a set of negative integers. Now this whole integer set, it can be represented as Z, capital Z over here. Okay, we'll remember this one as well. Now let's move on. Let's talk about natural numbers, another variant of integers. Okay, so let's say why we use natural numbers. Let's say somebody gave us some apples. Okay, and they told us, can you count this number of apples over here? What we'll say, it's a count of 4 over here, right? There are 4 apples over here. So if you see these numbers 1, 2, 3, 4, 5, 6, this we use in our day-to-day life for the counting purpose, right? So that's why these numbers are called natural numbers. Okay, so they mostly used for the counting purpose. Now there are various kinds of natural numbers as well, like ordinal number and those stuff. We will not go that level, it may not be necessary at this point. Okay, so the set 1 2 3 4 is called the set of positive integers as well. Also it calls the set of natural numbers as well, and we represent them with a capital N. Okay, this is the official, like whatever we are talking about, this name of the set, the letter we use to denote that particular set, these are all official way of denoting them. Okay, now think about this one. When we count, we also say like we have a zero count over here. We did not included zero over here, right? So there are some natural number definition where we include zero, but most of the cases there, if we include zero, we give a separate name for that particular set. Okay, and the name is whole numbers. So if we just talk about, so whole number includes all the natural numbers with zero as well. Okay, so this is the set for the whole number over here, and these are also called non-negative integers because there is no negative number in this particular set over here. Okay, and there is actually no official symbol for the whole number, but generally we express this as capital W, that particular set over here. Okay, so we understood integers. From that we talk about natural numbers, we talk about whole numbers, right? If you see, like these are all we can derive from the integers only. We talk about the set of negative integers as well over there, right? Now let's talk about another kind of number called rational number. Now we talked integers before rational number, because if you see the rational number definition, okay, so a rational number can be written as a over v, where the HCF of a and b is 1, that you have to remember, and a and b has to be a integer, and b cannot be equals to 0, because if b equals to 0 it will be undefined, right? So b is not equals to 0, a and b are two integers. Okay, suppose, let's say, okay, before I jump into that example, and now if you see it over here, this rational number we can express it as b a over b over there, right? And if b is becoming 1, then what we get, like whatever number we have as a, let's say 3, if b is becoming 1, it will become 3 over 1, that means 3 only, right? So if b is 1, then it becomes an integer over here. That means an integer is also a rational number, which can be expressed over here as a over 1, correct? So that means we are talking about a superset of integers over here. Okay, so now another thing is, as we can express that number as a over b, right? So that we will definitely get, for those numbers where a is not divisible by b, we will get a decimal part of that particular number, right? And that decimal part for the rational number is very important. It can be terminating, okay, or it can be recurring. So what do we mean by terminating and recurring over here? Let's say we have this particular number 1 over 2, okay, as 1 is, if I just divide 1 by 2, we will get 0.5, right? So that means we will get only 5 after decimal point. So that means it is a terminating decimal number. Okay, now let's talk about another number over here. Let's say 1 over 3. Okay, so we'll get 0.3333. It will never terminate over there, right? And the 3 will always occur every time over there. So that's why it is called recurring. Okay, so it is either terminating or recurring over here. Okay, so that's the property of a rational number. It can be expressed as a over b, where a and b are integers, and HCF of a and b are 1, and the decimal part of the rational number can be terminating or recurring over here. Okay, so we got the idea of the rational number, and we also established the fact that an integer itself is a rational number, because if b is 1, it will be an integer over there. Okay, and the set name we always expressed as q over here for the set of rational numbers. Okay, we'll remember this one over here as well. Now let's move on. Let's talk about irrational number. Okay, and if you see, like every slide we are seeing, we already have this numbers, this number lines over here. That means whatever kind of number we are talking about over here, all are real. Even like if you study the mathematics or basically calculus for the 12th standard, we will be mainly talking about the calculus of real numbers. Okay, there is a vast mathematics topics on calculus of the complex numbers, which we will be covering maybe in a separate playlist over there. Okay, if needed. So what is irrational number? So compared to the rational number, the irrational number cannot be written as a over b. So you cannot express that as a over b. And also the decimal part of the irrational number, it is not terminating, even not you can express it as a recurring over here. Okay, so it never terminates, even it never recurs as well. Okay, that means the same, it do not have any kind of pattern over there. Okay, for an example, a couple of couple of examples of the irrational numbers are, let's say, root over 2. Okay, or the famous example is pi over here. So if you see the actual value of the pi, it could be something like this one, from 3.145159265355897. It's go on, it never terminates. And if you see, there is no pattern over here. For rational number, we talked about 1 over 3, right? Over there 0.33333, it was the 3 was repeating every time. That means it was recurring every time. But for pi, none of this one are recurring over here. Okay, that means there is no specific pattern over here to establish that it's recurring over here. Okay, so this is the fundamental nature of the irrational numbers over here. So we talk about lot of numbers, right? Real numbers, then we talk about variant of integers, different kinds of integers like natural numbers, whole numbers. Then we talk about rational numbers, irrational numbers. Now let's take a bird's eye view about all these numbers together. Okay, so it will be something like this one. So all as I said, whatever numbers today we have discussed about, all are real numbers because they can be expressed on a number line. As we have seen in all our slides, the only one thing was constant was the number line over there, right? Now the set of real numbers can be subdivided into irrational number and the rational number. So for the irrational number, it is, as we have seen it over there, it is non-terminating and there is no specific pattern over here like e, pi, root 2 over there, right? For the rational number, as we have seen it, they can be represented as a fraction or a ratio of p over q over there, right? Now this whole rational number stuff can have subsets, something like integers, where it do not have any kind of fractional part of it, like 0, 1, 2, okay, minus 1, minus 2, this one. Now among all integers, where we are only taking the positive numbers, that too from, and we are including 0 over there, that means 0, 1, 2. Okay, this is called the set of whole numbers over here. Okay, and if we just exclude 0, okay, we will get a set of natural numbers over here, 1, 2, 3. And these stuffs are used only for the, not only for the counting, but mostly used generally it derived from that human natural counting part. Okay, so hopefully we got an idea about what are the different kinds of numbers over here, and we mainly deals with the real numbers over here. Okay, in the next video we'll talk about intervals. Okay, see you in next video.